So in this episode, we're going to be doing section 1 of the 2024 CTF. This was a fantastic CTF. There is another conference coming up in 2025. I believe it's in May. So be sure to check that out. There'll be a link in the description for you to register. As well as if you have not yet watched the One Request to Rule Them All CTF 2025 from API Security, I also strongly encourage you to watch that. There'll be a subtitle right here where you can click on it and go watch that after this video. So to get started, this is going to be, like I said, the first section, multi-part series, and this is under construction. Looks like there is a web app on the target URL listed below, but the front end hasn't been built. Maybe you can use the API to get some flags. The first one seems pretty simple, and we have this target URL here. So let's go over to this URL. Let's see what we have. So we do have a web page, but it says that it's currently being worked on, and the API is on the /API endpoint. So we can come here and we can visit the doc. We see that there is a Note API version 1.0, so maybe we have to deal with versions, who knows? And the base URL is /API, something very important to remember whenever you're testing an API. So let's look through a few of the endpoints. It looks like we can access notes. We can look at our own notes. We can register. We can log in. There's a health check to see whether or not the server is up, and a flag with a GET request. So I'm assuming this is what we're going to have to target, and it looks like we need a session bearer token to access this, which makes me assume that we're going to need a first register user. So let's head over to the terminal and let's go to curl and let's start this up. So we're going to go over to this website and we'll take this, we'll paste it in here, and we're going to do register, and this should actually be a post now that I think about it. So it should be a post. We're going to want to do parameters. So we're going to want to do tag data or tag D. Let's do JSON, because since this is an API, most of the time JSON is the appropriate parameterization. So we'll do username, and we'll just set it to MRE security, and we'll do password, and we'll also set it to something along the lines of, let's just say subscribe. After that, I think that looks good. Let's click submit, and invalid username or password. Well, we don't have a username or password, so let's see if maybe we could do a different one. So let's see, MRE, please subscribe, invalid username and password. So this is super strange. This is actually because if you continue to do this, obviously it's not going to work, is putting a header, right? So we could do content type, and we could do application JSON. See if that works. We still get that same error message. However, if you go to application and you do x form URL encoded, we can get rid of these. And instead of doing something along the lines of this, so we'll get rid of all this data. Instead, what we could do is we could just do username is equal to MRE security. And we could do the password is subscribe. This may take a second, but as you can see, the user MRE security was created. That's because sometimes whatever the developer really feels is necessary, they'll use the form URL encoded content type, or they'll use application JSON. So always make sure to check both of them. If something doesn't work, try to change the content type. If that doesn't work, there may be something wrong with the endpoint. So now that we have a user set up, we can go back over to the documentation and we could see how to log in. It looks like the form parameters are username and password. So all we have to do really is not move too much of this, just simply change API register to API login. When we click enter, we could see that we do get a session. Now, at the beginning, we did say something about get flag, and that required a session bearer token. So let's head back over here, and we could do a curl command, and we'll do a get request to, again, this URL, and we'll do flag. We're going to need to do the authorization, and then we'll do bearer, and then we'll add this session in here, and that looks to be good. I think everything is sound there. So let's click enter, and we get the first flag. No browser needed. So let's come over here. Let's submit the flag. There's another flag within the API. Now, we don't really know where this flag is, and we're kind of assuming that it has something to do with the notes, either that we create or that someone else created. So it looks like the admin says something about checking my notes. So if we go back over here, we can see that there is a get note ID section with the path parameter of just ID, meaning we don't really need to do much. So let's go back over here and let's just curl, and instead of API flag, let's just do API note and then 1. And it looks like there's just going to be a bunch of random data here. So what if we do 2? 2 does not exist. 3 also does not exist. Okay, so moral of the story is we're probably going to have to create a script to brute force this identifier. I don't know how big it's going to be or how long it's going to take. So let's quickly do a brute force script. So brute.py. Let's copy over this authorization bearer token because we're going to need that. And let's start doing it. So we'll import requests, and we will also come down here and we'll do base URL, and we'll make sure to add the URL there in just a second. We're also going to need headers. So we're going to put this inside of JSON, and this is going to be the authorization token. What else do we need? We also need a for loop. So for ID in range, let's do 1 through 500 to start. So now that we have the for loop, we're going to need to set the response to be the request.get, and then we're going to do an f string for format, and we'll do the base URL ID as well as the headers is equal to headers. So we'll do if, let's say, APISEC in response.text, we will do a print response.text. So all we have to do now is we have to just put the base URL in here. So we'll copy over the base URL, we'll paste it into here, and we'll do note and a slash there, and that should be everything. So let's try this out. Let's go back over here and we'll do Python 3 brute.py. Looks like it's going. We're not going to receive anything unless it finds APISEC within the body of the response. So this may take a second or two, but essentially what we're doing is something called an IDOR attack or an improper authorization. However, you can see other people's notes even if you didn't submit that specific note. So this is a common vulnerability within web applications. So we're doing something wrong. Let's see, what are we doing wrong here? So we do need import JSON. You can also do an exit here in case it does find it. This may take another second, so I'll cut. All right, there we go. And it looks like it did work this time. We had to put the import JSON in our script in order to get it to work, but the body is APISEC. That's just IDORable, which is kind of a funny flag name, and we could throw that into this challenge. This was the first section of the API security challenge. The next set of challenges I'm going to show you now, and here where you could quickly pause, take a screenshot, and try to solve these challenges before the next video comes out in 2 to 3 days. So make sure to take a screenshot of these challenges. We'll go through them together in 2 to 3 days. If you have any questions about them, feel free to shoot me a message either through Discord or in the comment section down below. But please like, subscribe, and I'll see you in the next one. Take care. In this episode, we'll be taking a look at how to attack JWT tokens within the Endpoints section of the CTF. The first challenge is named JWT Germinator, where Soran has tasked us with taking care of an ENT for the upcoming war. Using the API to monitor its growth, Sauron will only award you when your ENT has finished growing, and we have a target URL here. So let's head over to the URL and see what we have. We have 5 endpoints, 2 of which look to be interesting. One is retrieving tokens using the ent_get_seed, as well as the check seed, where we have parameters here that we can maybe play around with later down the line. So to get started, let's take a look at how we can retrieve the token. So we'll head over to our terminal, and we'll do a curl request to this endpoint by doing a post. Now, if you don't know what JWT tokens are mainly used for authorization purposes on web applications. But in our case, because this is a CTF, we're going to be fiddling around with it using parameters. There are some times where you will get JWTs in parameters. They're not very common within web applications, but these are just a few attacks that you can do on JWTs. There are 3 main sections in a JWT. The first section, which can be delimited by a period. This is the header section, this is the payload section, and anything after the second period would be the signature. Now, each time you generate a JWT, it's going to have different values because of maybe an expiration date or something changed within the JWT. But in our case, we're going to want to look mainly at the payload section. So let's do an echo on this base64, do a base64 tag D, and we can see we get a name as well as time left in years, which is 8 million. If we look back over to our original challenge though, we could see that the reward is only when the ENT finishes growing. So that probably means that we need to tamper with the time left in years. So what we're going to do is we're going to head over to the echo command again, and we're going to take this JSON and we'll paste it into the echo command. And what we could do within here is we can now modify the payload. So we're going to change it from 8 million to 0. And we're going to also base64 encode it again. This is a completely new base64, right? These two are completely separate from one another. So what we could do now is we could take this original JWT and we'll remove the original payload because we're not going to need that anymore because that has the 8 million value. And we'll paste this in. So now we have a brand new JWT. So now that we have the new JWT, what we can do is we can do a curl on that check seed endpoint. So we'll do a post, and instead of get seed, we're going to change this to check seed. And we're going to need to do a tag D for data because we have a post parameter. And if we remember from previously, we could see that there is a seed token parameter. So we're going to do JSON here, and we will do seed token colon. And inside of the quotes, we will paste in our JWT that we just created. And this may work, this may not work, depending on how curl analyzes it. We may also need to throw in a header, the content type of application JSON, but let's see if this works. And it looks like it doesn't. It says unsupported media type did not attempt to load JSON because the content type is invalid. So we have to do a tac H for header, and we'll do a content type colon application JSON. And now when we submit it, we could see that we retrieve the first flag. How'd that grow so fast? So let's head back over to our documentation and let's paste in the flag. So in the next challenge, Soran is unhappy with those who have found a way to bypass the expected wait time for their ENT to properly mature. There has been a new API release for use, which has added security measures. Do not disappoint him again. All right, and we have a target URL. So let's copy this and let's see what we have. Looks like it's the exact same endpoints as last time, so should be pretty easy. We'll take the URL and we'll do a curl techx post, and we will do ent get seed, and we can see here that now we have a signature. This was not here before. If you remember, there was nothing after the second period. Now there is. So this makes me think that we're going to have to do something with the signature, but we're going to try the same stuff that we did originally, and we'll take this, we'll do an echo onto the base64, and we'll decode it. We can see everything still looks the exact same. So again, we'll take the JSON, we'll paste it in, and we'll change it to 0. We'll base64 encode it again, and we will take the original, which I'm actually going to put it inside of our notes here. So we're going to take the original, and we'll take the base64 that we just created and we'll paste it into the payload section. So now that we have the new one, we're going to go back to the get seed and change it to check seed. We'll do a tac D. And again, what we're going to do is we will do JSON. So 2 brackets, seed token, and we'll paste in our brand new base64. Don't forget about the header. So content type, application JSON. And we can see invalid token signature verification failed. So we can't do anything modification related to the payload because the signature prevents us from doing so. So there's a specific thing that probably comes to mind, which is let's just brute force the signature, right? At the end of the day, a signature is a password, which is exactly what we're going to do. So what we're going to do is we're going to get a brand new seed that we have not created. So let's take this and let's make a new directory. Let's just call this JWT. And let's go over here and we'll put this as a hash for hashcat. And what we'll do is we'll do hashcat tech A0 tech M 16,500. We'll do hash as well as user share word list, and then we'll do rocku.txt. We'll let this go, and after a few seconds, as you could see, We already retrieved the password, December 30. So there are a few different ways that you can now tamper with this specific JWT. In my case, I'm going to make my life a little bit easy. We're going to head on over to our browser and type in jwt.io. jwt.io is a fantastic tool. If you haven't used it, I strongly recommend you check it out. Essentially, what you could do here is you can modify JWTs in a beautified form. So here you can put the encoding, and here there will be the decoded version with the header, the payload, as well as the signature. So what we can do here is, instead of this signature, we'll replace it with December 30, and we'll change this out to be 0 in the time left in years. And as we can see, signature verified, which means we're good to go. So let's copy this and let's head back over to our terminal. And we'll do a curl request again onto the check seed, but this time, instead of the old, we'll put in the new. And we could see APISEC, are you a time traveler? That is the second flag for the second challenge. So we'll head over here and we will paste this in to our challenge. Now we're on to the final challenge of this section, but before we do so, please like this video and subscribe to the YouTube channel. It helps me out to create more content for you guys to learn and grow within web application security and API security. In this challenge, Garden of Tokens, I did not receive points for this challenge when I originally did the CTF, but over time I managed to figure it out. But it says, apparently you can't be trusted to properly take care of these ENTs. There we are now tracking all ENT data centrally. You can only retrieve your flag once your ENT has sufficiently matured. And we have another URL. So let's head over to this URL and see what we have. There are 6 different endpoints now. Looks like we do have new ones. So there's a seed/new as well as an ENT/seeds. And we have different parameters. So we have the name parameter inside of the new, and we have the C token, which is within the check. So to begin, I'm pretty certain we're going to have to look at all the seeds to see what we're working with. So let's do a get request on the seeds. So let's head over here, let's grab the URL and we'll paste this in /ENT/seeds. And we can see that there is a bunch of different things, but it's a bit difficult to read. So we'll be using something called JQ, which will essentially beautify our JSON within the terminal. And we can see that we get a few seeds with different names and planted dates. So there really isn't much information here, but we do remember that in the 4th endpoint that we looked at, there is a name parameter inside of the seed new. So we'll head over to ENT seed/new, and we're going to change this over to a post request. And inside of the data, we're going to set the name field to be whatever name that we have within the JSON that we have above. So we'll do Ricky Suarez first. And we'll also add the content type again to be application JSON. And it looks like there's an issue. So it looks like I forgot to put the name parameter. So if you did spot that, good catch. So plans already exist with the C token, and we have a token. All right, so this is some great progress. So what we can do is we can copy this again. We'll head over to the jwt.io website, and let's take a look at what data we have. So we have the name, we have the planted date, which we already know, and now we have the time left in years. And it looks like this seed is not going to expire anytime soon unless we want to wait 5 years, but we don't have that much time. So we're not going to worry too much about that. Let's head back over to our terminal and let's try a different user. So if we scroll up, we have Jonathan Monroe. Let's head over to Jonathan and let's modify the name to be Jonathan Monroe. And let's encode, and we could see that Jonathan has a time left in years of -15. So this is promising because this is less than 0, which means the ENT should have matured by now. So let's take this, head back over to our challenge, and we're going to modify this just a little bit. So we'll keep this as JSON, but instead of this being Jonathan Monroe, we'll replace that with the JWT token that we have, and we'll change this to seed token, modify the endpoint to check. When we click enter, we see that we have retrieved the final flag of the challenge, APISEC. Thank you for your efforts in helping our garden grow. So we'll take this and we'll put it into to our notes. And that's all for this episode. Thank you guys so much for tuning in. If you haven't already, please subscribe and like this video. It definitely supports the channel. This is going to be the next section that we do. It's called Insecure Runes. So be sure to take a screenshot of this or pause the video now. In 2 to 3 days, I'll be posting the write-up for how to do this challenge. This was a fun one. Want to see if you guys can get it. If you did, please be sure to leave a comment in the comment section down below. And please like, subscribe, and I'll see you in the next one. Take care. In this episode, we're going to be looking at Insecure Runes section from the CTF. If you missed parts 1 and 2, be sure to check them out in the description down below. Let's get started. So in the prompt, it says, looks like the orc devs are back to working for the mages. Unfortunately, some of the mages are complaining about rune references being mixed up. It's been said that there's a secret way to access the flag, but we've yet to find it. And there's a target URL here, so we'll head on over to it. And it looks like there is one endpoint that we're going to be working with, which is rune create. We have the post method, and here are the parameters that we're going to need to use. So let's head on over to the terminal, and we're going to do a curl command, tac x for method, and we'll put post here. We will copy over this URL, paste it in, and we'll also add the rune create. We'll also add attack D for data, and we'll supply it with the JSON data that we need to put in. So in our case, it'll be rune, colon, and then some random stuff. We'll just put test for now. In addition to that, because we're using an API, most of the time APIs are going to need a content type, whether it be application JSON or application x form URL encoded. In our case, we already know that it's going to be JSON due to the fact that in the description of supply, it says the rune with squiggly brackets indicating JSON. So we'll do content type, and then we'll do application JSON. And when we submit it, we could see that test is not defined. And this looks to be a Python error. So we could try a few different things with this. We could try to just see if maybe we could type in rune. Rune is not defined. Maybe we could type in memory security. Also not really working. Maybe there's some form of XSS payload that we need to play around with. Maybe there's something in the back end where a bot is trying to log in and we need to retrieve something. And it looks like the rune is too long. So we have here that whenever we supply something and it's not defined, we get an error message. But if we supply something that is a bit lengthy, we also get rune too long. So there's a few things that you can do when it comes to Python, specifically APIs, is you always test for SSRFs, SSTIs, stuff like that. So we can try Jinja 2 SSTI or server-side template injection. So if we do 7 times 7, we could see that your rune is 49. So it looks like we are getting something having to do with SSTI. I'm not really sure what it is, but we do get 49. 7 times 7 is 49, meaning that there's something going on in the back end. Maybe it's executing something in the back end, it's evaluating something in the back end, but it's safe to assume something is going on. We can go over to something called payload all the things, and this is a fantastic GitHub where you can find a bunch of different attacks. In our case, we're going to be looking for SSTI. So let's scroll down a little bit until we see server-side template injection. And they have a few here. We're going to select Python because we know that it's most likely going to be a Python server in the backend. And we see that there's basic injections. So we could try this basic injection, config.item, and let's just see if anything works. Let's see if we paste it in. Config is not defined. All right. Maybe we have to remove the squiggly brackets. We see that config is still not defined. All right. Let's try a different payload. And let's see if this works, and rune is too long. So obviously this is not the path. We're not going to be looking at SSTI. This is obviously something is wrong with it. So we'll head on back over here and let's just try something as basic as flag. And we see it says result is nice try. So this is something different that we haven't seen before. Maybe we could do flag exclamation point. No. How about flag double exclamation point, and we get an invalid syntax error. So that's not it. Maybe we got to remove one and we still get the string line 1 is invalid. Remember how I said something about evaluation injection or code injection, something along those lines. So let's take a look at some command injection attacks. So we'll look up command injection payload all the things. And when we go over to the command injection, we see that there's a bunch of different ways to bypass. So we'll click on one of them and we'll see what happens here. So we can do a $sign with squiggly brackets and then IFS. We'll see if this works. Maybe we could put it in the middle and it looks like we get invalid syntax. So that's obviously not it. So let's try the @ sign. Let's see if we can maybe get something here if we put the @ sign. Instead of flag, we'll do flag with an @ sign. Maybe it needs that obfuscation. And it does remove the @ sign, which means the @ sign is valid, but we only get FLG. There's no A. So let's put the A back, and we see that we obtain the flag. APISEC, the devs are orcs. So another way to obtain the flag is by using something called the global variable, which is a built-in function in Python. So if we type in globals and then we put in parentheses, we could see that a bunch of different variables are being sent back to us. We have the routes, we have a bunch of different things. We have the file structure of where everything is located. And we see here that there is the flag. Another fun thing that you could do within it is you can do __ and then file, and this will give you the exact path of where the application is being stored on the back end, which is also kind of a neat trick. I wish I could see the code so we can walk through the code together, but I don't have the code. So let's copy this flag and let's paste it into our notes. Here are the next set of challenges that you can begin, the Sauron Firewall. These were very interesting, a little bit challenging, so take your time with them. If you have any questions, you can hit me up on Discord, LinkedIn, or in the comments section. But best of luck on trying out these challenges. Please like, subscribe, and I'll see you in the next one. Take care. In this episode, we're going to take a look at Sauron's firewall section of the CTF. If you missed other parts, be sure to check them out in the description down below. Let's get started. So we have the challenges here. There are 3 of them in this section. And the first one says, "Come at me, Sauron." Sauron is pretty against his orcs using social media, which is why he only allows them to use this URL. Only there does he allow his flags to be sent. Can you find a way to retrieve the flag? Already, right off the bat, it sounds more or less like we're going to have to bypass the firewall that he put in place. And there's a target URL here. So let's head over here, and we can see that we have a endpoint proxy, and this takes in a post, and we need to supply it a URL parameter. Whenever you see a URL parameter, the first thing that should come to mind is server-side request forgery, or SSRF. This is typical for an SSRF vulnerability because whenever you have to deal with URLs, most of the time you're going to try to access internal server information, whether it be internal services, a website within it, or retrieve files from the internal. From here, let's head on over to our terminal, and we're going to do a curl request. We'll make it into a post, and we'll take this URL that we have, and we'll add proxy to it, tech D for data, and we will put this in brackets, URL, and HTTP sauron.com. Last but not least, we're going to also need to do the header because this is an API and we are working with JSON. So we need to do application JSON. And it looks like I missed a quote here. So let's fix that. And we can see that we get error, invalid URL, or no response. It's typical because there is a firewall in place. But if we head back on over to the challenge, we could see that the name gives us a hint. Come at me, Sauron. The @ sign. So we're going to head back on over to the terminal, and we're going to use something called interact.sh. If you do not have interact.sh, head over to your browser and type in interact.sh from Project Discovery. If you scroll down a little bit, there's going to be a Go package that you're going to install, and then you should have access to this interact.sh. So within it, you could just click enter, and now we have a site that we can use. So we'll take this and we'll see what we can do. We'll open up a different terminal in the meantime, and we'll just set this in the background for now. Right off the bat, we're going to do another curl request, and we're going to grab this. And a bypass technique that we can do is we could just put an @ sign and we could throw in this site. Think of it like SSH. When you go to SSH, you have to put in a username, @ sign, and then the URL or the IP address. In this case, think of it just like that, right? We're putting in the quote unquote username, which doesn't exist. We're putting an @ sign, and then we're telling the server exactly where to submit the request. And when we do that, we can come back over to our application here. This may take a second, but we can see that a few requests have come in. We can see that an HTTP interaction is in place. So what we can do is we could put in -HTTP- only, as well as verbose, to see the request that's coming through. And we'll take this new URL that we have and we'll supply it in our curl request, just like so. And we could see that we get a success true. And if we go back over here, we could see that we retrieved the flag in the post request. So the I didn't see this coming. Perfect. So we'll take this and we'll submit it. The next challenge I did not receive points for. As a matter of fact, the next 2 challenges I did not receive points for, but the next challenge is bypass the Dark Lord's firewall. So Soran is still adamant about restricting his orc's social media usage, allowing them to access only this URL. Only to this domain will he securely transmit his flags. But that trick, the @ sign, isn't going to do us much good. Now he can't do that, right? He's completely blocked us from doing the @ sign. It looks like we don't have any additional endpoints, so we're going to stick to the original. So we'll come over here and we'll enlarge this a little bit, and we will do firewall 2 inside of the URL, and we can see invalid character found, @ sign. This treatment will not be tolerated. All right, what else can you do with the URL? You can try to do a subdomain, and essentially all we're going to do is, instead of doing Sauron.com @ we're just going to replace the @ sign with a period, and let's see if maybe this will work. Oh, looks like it did. So we'll head back on over to the application. If we scroll down a little bit, we can see I might need a new filter as the next flag. Pretty straightforward, right? Nothing too crazy so far. So we'll come back over here and we'll submit the flag. Last but not least, we're going to do the final challenge. Soran's grip on his orc's internet access remains tight, limiting them solely to this URL for all communications. His security measures have grown even more sophisticated. Do you have what it takes to penetrate his enhanced defenses and capture the flag? And we have a URL here. So we'll go over to the URL. We'll see what we have. Looks like the exact same endpoint. So we're not going to play with that. We'll just come back over to our original and we will move it on over to firewall 3. And we can see not allowed. URL must contain http://sauron.com. Because it needs to do that, what we could try is we could try to just give off our URL, and then at the end we could try to just put maybe a /sauron.com, see if that works. And no, we still need to put http. What is something that we could do? Well, what we could try to do is we could still try to manipulate this request by still keeping it as Sauron. So we could do sauron.com, but we'll make ours into a directory. So we'll just put a / and we'll leave our URL the same. We still get an invalid URL, has no response. So that's also not going to work. What can we do? Well, we could try to go back to our original thought process, which was get the URL. So now instead of using Sauron.com as our directory, what we're going to do instead is we're going to just append HTTP onto this directory and see maybe if it'll work. And it looks like it's not. And it looks like we also need to add a / at the end here. So if we come back over to our terminal and we scroll down just a little bit, we can see that we get HTTP Sauron.com. However, we're not receiving any additional information from the server. So this is a bit weird. So within this request, we did not receive the flag, right? We don't see any flag, but we do have the request. So we need to think of a different way to go about bypassing this. We need to have the HTTP. When we do it, we could see that we get success true, but we're still not receiving the flag. Something is going on in the back end. So after speaking with the developers, we were able to solve the problem that I was originally having with challenge number 3. So let's get started. So let's head back over to our terminal, do a curl command. So now that we have the curl command situated, we've already done subdomain. We've already used the @ sign to retrieve the previous flags. What else can we do with a URL? We can try to use the URL as a directory. So in this case, because this challenge is a bit unique, for whatever reason, the interact.sh proxy that we were currently using was not working for some reason. So we're going to head on over to Google and we'll type in request bin. And we'll navigate to the requestbin.whapi.cloud, create a request bin, and we see that we get a URL. So we'll copy this URL and we'll paste it into the URL parameter that we have associated. And we'll change this over to proxy. So /proxy, we see that success is true. And if we go back to this website, if we wait a second, we'll see that there is a JSON. So let's click on this. And we see that the JSON shows here, these filters are a joke. And we see that we did get the request perfectly. So we'll copy over this flag and we'll paste it into our challenge. And that solves the Sauron's firewall. So thank you so much for watching this walkthrough of the API Security 2024 CTF Section 4. I hope you enjoyed it. Here are the next set of challenges for you to check out. There are 2 called Blogger, as well as, if you want, there's also a bonus. Try to see if you can find the bonus flag and let me know in the comments down below if you did. Please like, subscribe, and I'll see you in the next video. Take care. In this episode, we'll be taking a look at the blogger section of the CTF. If you haven't checked out the previous episodes, be sure to do so in the description down below. Additionally, before we get started, please like and subscribe to the channel. It does help us out with creating content for penetration testing. Let's jump right in. First challenge, role reversal. It says, check out our new blog. Well, the API at least. Now featuring draft posts, we think it's pretty secure. So we've added a special flag in the admin account that only other admins are able to see. And we have a target URL here. So let's head on over to this URL and we could see that we get just a message, hello world. And it doesn't look like there's any documentation to the API. So what we're going to have to first do is we'll have to do a brute force of the directory. So we'll do a gobuster command and we'll do a dir for directory, tech u for URL, and we'll paste in our URL here. We'll do a tech w for word list and we'll do a user share word list and we'll do a dirb. And we could try just common.txt to start out. Click on enter. We could see it go through and we are getting rate limited with a 503 status error. So we could try to do threads. We could try to do various different things. So we could try to do just let's say 1. And this is going to take a few seconds and we'll see if we do get rate limited here. And it looks like after I did the cut, we are getting rate limited. So that's also not going to work. Well, what are some other things that we could do? Well, we could just try to do various different things like maybe a /v1. Let's see if there's anything there. And it looks like there's nothing. What about a /v2? We could also try /docs. And we could see that we get a fast API. And that's something that you could do if rate limiting does occur, is you could try to just start guessing random different directories. Most of the time when it comes to APIs, you're going to see something along the lines of v1, v2, API/v1, API/v2, docs, document, something along those lines to try and identify the documentation for the specific API. So it seems that we do have a few endpoints here. We have an auth, a post, as well as a user endpoint. And we'll start out with the basic, right? We're just going to sign up and we're just going to see what we have to offer. So we will go here and we'll do try out and we'll paste in random information. So in our case, we'll just do test, let's say mresecurity.com. We'll leave it set to password and we'll do first name is please, last name, subscribe, and we'll click on execute. And we can see that we do get a success user created, and here's the curl command if you want to do it within the command line interface. But for this specific challenge, we're going to try to stick to only the web-based UI. So we now have a user set, so we can come down here and grab the login, and we'll click try out, and we'll paste in our email address. So test@mresecurity.com, and we'll leave it at set to password. Click on execute, and we can see that we get an access token. Now this is a authorization bearer token. So we can come up to authorize and we can paste in our bearer token here. So now every time that we submit a request, this bearer token is going to get injected into our request before it gets sent to the server. So now that we're signed in to the application, let's see if we can view our user to make sure everything is working properly. So let's click try it out and we can see that we are ID user 2. So because the IDs are being incremented by a number, let's just assume that the administrator is going to be ID of 1. So we'll head back over to users and we'll try to access the ID of 1. Click on 1, click execute, and we can see that we do have an admin user set to ID of 1. So what we could try to do is we could try to take the role and make it into an admin for our specific user. But because of the way that things work within this application, we're going to have to register a new user. So looking at the ID of 1, we see that there is a role of admin. So if we put in this parameter when we use the sign up endpoint, we should be able to become an administrator. So let's head back up over to the sign up page. And we're going to modify this just a little bit. So we'll try this out and we'll put in again, test mresecurity. And we'll just do 1, we'll leave it as John Doe, and we'll put a comma. Inside of a new line, we're going to do a role, colon, and then we'll do admin. When we execute it, we could see that the user was created successfully, even though we did put the role there. So that's a good start. So when we go to log in, we can come back over here, and instead of that, we'll do test1 at mresecurity.com with the password set to password. We'll click on execute. and we could see that we get a brand new token. So it looks to be that this did work. We could head back on over to our authorize. Instead of this, we could log out and paste in our brand new value. So if we head back down over to the user/me, we could try it out and execute it, and we could see what our role is, and we could see that our role is now admin. So going back over to the user/ID, we can execute it. We see that we get the flag APISEC. Look at me, I'm the admin now. So we'll take this and we'll go back over to, and we'll paste the flag into our notes. So the second challenge says prying eyes prohibited. Since we just rolled out draft posts, we wanted to make sure that they're safe from prying eyes. If you want to see the stuff from someone else that hasn't been posted yet, you're out of luck. And we have another target URL here. It looks to be the exact same from the previous challenge. We're just going to stick to our current instance. So we could see that there is a password here. So we're going to take this and we can go over to something called CrackStation. If you don't know what CrackStation is, it's a fantastic resource which has a ton of different word lists that it brute forces and tries to figure out what a specific hash is in clear text. So we can come here, I'm not a robot, click crack hash, and we see that it was a SHA-256 hash and coolman1 was the password. So what we can do is we can head back on over to our login, and instead of the email being test1@emory-security, we can use the administrator login. So admin@maltechsolutions.com, and the password we said was coolman1. When we click execute, we see that we get the access token. So now we are ID1 or the administrator. Log out, log back in. And now we could look at the posts requests. So inside the post request, we could see all the posts that we have. So we know that we are number 1, and it looks like there is a draft boolean. So we're going to set the draft to true because inside of the challenge, it specified that we're trying to look for draft posts. So after executing this, we could see that we get the second flag, APISEC, I found your admin posts. We see here that we do get the flag. Head back on over here and we'll paste it in. Now within this challenge, there was a bonus flag. The developers forgot all about it midway through the CTF, and then they said, hey, if anyone can find the flag, you'll get points. And essentially what you had to do is look at the bottom here, and it said bonus. When you click try out and execute, it says this is only available to users who have been registered for more than 2 years. So if we head back on over to the users me, we can click execute, and we could see that there was a created time section as well. Now, if you remember, we just did something having to do with the role where we set the role from user to admin. It's basically the exact same thing, but instead of changing the role to admin, we're going to now change it from created time. We're going to set it back 2 years, and then we're going to get the flag. So we're going to copy this created time, and we're going to head back on over to the sign up page. And now we're going to modify this to say role is admin as well as created time. So we'll paste it in here. And instead of 2025, we'll just set it to, let's say, 2020, just to be safe. Click execute. The user already exists, so we're going to have to change the test1 to test2. Click execute. We can see that the user was successfully created. Head back on down here, go to login, and we'll log in again as test2 at emory-security.com, and we'll also put in the password set to password. We can see that we get another access token, so we'll copy this on over, and we will put it inside of our authorized section. So over here, paste the value in. And now if we head back down to the bonus section and we run it again, we can see that we get the bonus flag, APISEC, I built a time machine. So we'll take this and we'll paste it as the flag. So thank you all so much for watching this video on the Emory Security YouTube channel. If you haven't already, please like and subscribe to the channel. It really does help us out with creating additional content for you related to cybersecurity. If you're interested in the next set of challenges, this is Horde's Door, and there's 2 challenges here, so passcode to the dark vault as well as the unlock Sauron's gold. Try these out, let me know how they are. If you did solve them, be sure to let me know in the comments down below, and please like, subscribe, and I'll see you in the next one. Take care. The first challenge is passcode to the dark vault. It was 75 points, and it says it seems you found the door to Sauron's gold. Can you figure out the passcode? And there is a target URL here. If we got on over to the target URL, we could see that there is one endpoint and we have to supply it a PIN and a 4-digit number, as well as a post, and it's going to the vault endpoint. Whenever you see a PIN, whenever you see a password, the first thing that should come to mind is, does the application have rate limiting? We're going to just assume that we can potentially brute force the PIN, and that's how we retrieve the flag. So let's head on over to VS Code, and we'll create a new project, and we'll name it, let's say, pin.py. In here, we're going to want to do a few things. The first is we're going to want to import requests. We'll also want to get the URL, which we'll supply in just a little bit. We could do a for loop. So for PIN, let's say in range, since it's a 4-digit PIN, we'll probably want to keep it to 10,000. So 10,000. And essentially all that's going to do, it's going to go from 1 or 000 all the way up to 9999. And we'll do just another PIN string. And what we're going to do is format it to say we want the PIN value, which is going to be from the for loop, and we're going to want to format it to have zeros and digits. So if it's, let's say, a 0, it's going to put 4 zeros at the end of it. If it's 4s, it's going to put 4 4s at the end of it. It's just ensuring that it's formatted correctly to be at least 4 digits long. Because if we do a PIN, and let's say the range, right, it's going to go 1 2 3 4 5 6. Well, because of what our formatting just did, it's now going to go 00001. And then same thing for 2, and then same thing for 3, so on and so forth. So we will do the payload, and this is going to be our PIN that we need to set. So we'll put the PIN value here in JSON, and we will set the PIN string. And now we're going to do a response. So if the response is equal to requests post, and we'll put in the URL here, as well as, because this is an API and it is using JSON, we'll put JSON is equal to payload. And then we'll do an if statement. So if APISEC is within the response, so response.text, we're going to print correct PIN. We'll supply it the PIN string, and we will also showcase the response. So we'll also just do response.text. And because of this, we're going to want to exit out of our program because we're not going to need it anymore. And we spelled API wrong, so let's fix that. Now that we said exit, let's come back over here and grab the URL that we need. And let's also add the /vault at the end of it. So now this may take a little bit, so I'm going to come back when the script is done. Alrighty, and there we go. APISEC, that was incredible. So let's copy this and let's paste it into our notes. We'll click over here and we'll paste it in. And that's challenge number 1 complete. So the second challenge says unlocking Sauron's gold. The first door wasn't too hard, but can you figure out the next one? Sauron's gold is just beyond this door. And let's see some of the endpoints that we have. So it looks like there is a password as well as the value is also password. So it looks like the exact same thing, except we need to somehow brute force the password. So we can use a curl request just to see what the deal is with that. So let's open up a new terminal and let's do a quick post request. So we'll do curl, and then we'll do an X post, and then we'll copy over our URL /vault, and then we'll do an H for header, and we'll do content type application JSON. We'll do tag-d for data, and then we will supply it the password. And in our case, we'll just do something random. So hello, and we'll press enter. So it shows up as incorrect password. Now, what we could try to do is we can try to send this over to burp. So we'll just do proxy, we'll do http ://127.0.0.1 8080, and we'll also do attack K to avoid the SSL errors that we may be getting because we're using HTTPS for the URL. So we head back on over here and we go to history. We see that we get the post request and we also get the incorrect password. So let's send this over to intruder. And essentially what we're going to do is we're just going to see if what we get is valid or invalid. Let's see if there's some form of difference either within the responses, within the time, anything like that. So we'll go over here to hello and we'll click add, and there's these little squiggly brackets, and we have a few options here. Now, if you haven't used Intruder before, this can be extremely stressful and you're looking at all these different things and it's like, what do I do? Payload type is essentially what you want to do. In our case, we're going to keep it to simple list. If you want to, let's say, brute force numbers, which we could have done also with the pin, we could have used numbers and we could have set the from as well as the to, and then it would have brute forced the pin. But in our case, because we're going to probably want to do letters and numbers, we'll stick to just a simple list. Now, what you can do is you could simply add things one by one. So we could do like A, B, C. I'm going to cut back when I'm done with this. So after Intruder was done brute forcing all the 26 characters that we supplied within it, it looks like the time differential for the letter O is significantly more than all the rest. So it's safe to assume that we have about half a second delay between true responses as well as false responses. So what we could do is we could make a Python script to essentially loop through all these different kinds of characters. This is just an example, right? So this is just uppercase, but in our case, we're also going to add lowercase to our script, and we're going to add a time delay to see whether or not a value is correct. Let's head on over to our VS Code and let's name this, let's say password.py. So after we create the password file, what we're going to want to do is we'll do a import requests. We'll also import strings. This will just help us with the ASCII characters that we have to set. We'll also do time. We'll do a URL variable, and we'll set the URL in just a second. Set the password as well as the char, and we'll do strings, ASCII, lowercase, and we'll do the same thing, except this time we'll also add uppercase, so uppercase. While true is going to have an infinite loop because we want this to continue until we tell it to stop. And we'll do a max ellipse time. We'll set that to 0. We'll do a baseline time, and we'll also set that to 0. And we're going to also want the best character. So if, let's say, the response time is greater than all the rest, we want that to be our best character. For now, because we won't have anything set, we'll set that to none. So now we'll do a for char in characters, and this is going to loop through all the characters that we previously set in row 9. What we're going to want to do is we're going to want to do a start time, and this is just going to be a time.time. We'll get the response by sending a post request to the URL. And because we are using a JSON API, we're going to set JSON as well as data. What we could do then is we could also set the data. So we'll do data is equal to, and we'll just set this to password, and we will add the password as well as the char to it. So we can make that into a format string by putting an F in front of the quote. And then what we could do is underneath that, we could do an end time, and this is going to figure out a way to stop the timer. So we'll just do an end time there, and we'll set the elapsed time to end time minus start time. And what this is going to do is this is going to get us the exact amount of time from when the request was sent to when the server received the request. Now that we have that, we could just do a print, and we could say, trying, let's say password, and we could do a password with the char attached to it, so we could see exactly what it's doing. We could also do a response time, which is going to be the elapsed time, and that's going to be a format of 2. So we want 2 decimal places, and we'll also just add seconds in there as well. If elapsed time is greater than the max elapsed time, we'll set max elapsed time to elapsed time, as well as the best char is equal to char. If the max elapsed time is greater than the elapsed time plus 0.5, because we saw that it was about 0.5 seconds above all the rest when we looked at the burp suite intruder, we will just add a character to the password variable, and we'll set this to best char. We'll also print something along the lines of found password char, and we'll insert the password here, and we'll break out of the for loop so it can continue again. We'll also want to check to see if incorrect password is within the response.text. So in response.text, we're going to want to set the password char as well as the password. So password is found, and we'll also set the password there. And this should actually say if incorrect password not in the response.text, we want to say, hey, the password was found. And we also want to sprint the response.text as well as exit out of the program. So that should be all. And it looks like I need to just add some format strings to all of my print statements. So let me quickly do that. So now that we have everything set, let me just quickly run through exactly what's going on in case this may be a little bit confusing. So what we're doing at the top here is we're setting all the characters that we need for the password. So it's just uppercase and lowercase characters. Think A, B, C, uppercase and lowercase. We're doing a while true loop. We want this to go forever until we retrieve all of the password. So once everything is done, we'll retrieve the flag and the while loop will crash because we put an exit function at the end. These variables are being preset, and we loop through all the characters using the char variable. We get the start and end time from the request to the response. We grab the elapsed time for how long the response took, and then we printed out the specific response time as well as the characters that were set for the request. We check to see if the elapsed time is greater than the max elapsed time, and if it is, we want to set the max elapsed time to the elapsed time, getting the best character. But if the max elapsed time is greater than the elapsed time plus 0.5, so let's say the first one we saw that O was 0.5 seconds, but the rest 0.1 seconds or something along those lines, we can now determine that that's probably the character that we need to set for the next char. So we'll set the best char and we say that the char is found, and then it'll just continue this cycle until it doesn't receive the incorrect password and it receives, an APISEC flag. So let's go over here to Python 3 and we'll do password.py, and it looks like I didn't import strings, but I did. So there was a typo inside of the import. It should just be import string, not import strings. Save that. It's also a typo inside of the chars, so inside of the characters. So after we fix that, let's see if there's any errors, and we just need to supply, of course, the URL, and we'll do /vault. When I click enter, I keep just having a bunch of misspelled errors, so we'll just quickly replace that so that way everything is fixed there. And now we can see that everything is going through. Everything seems to be set to 0.05 except for the O, and we get 0.55, which determines that I think we got the right thing. So let's move on to the next one. We see that found password chart, and it goes through the next set of characters until it reaches 1 second. So now we have OP. Looks like it found OPE, and this is going to continue, but because of the way that the program is set, each request is going to get longer and longer and longer. So I'm going to pause this video until we retrieve the flag. So it looks like the brute force are finished and the password was open sesame. We retrieved the flag APISEC. Time is of the essence. So let's copy this flag and paste it into our notes. And that's all for today's episode. I hope you guys did enjoy. If you did, please like and subscribe to the YouTube channel. It really helps me out to pump out more content for you about web application security, API security, and anything pertaining to cybersecurity. If you do want to do the next set of challenges, they are here down below. There are 2 additional sections. The name of it is called Uber Orcs, and there are 2 very interesting challenges. Definitely recommend checking them out. If you do solve these, let me know in the comments down below. And please like, subscribe, and I'll see you in the next one. Take care. In this video, we'll be taking a look at Uber Orcs. The first challenge is, did someone order a flag? The orcs gotta eat, right? Luckily, Soran is always there to help every orc with their needs. And he included coupons. What a guy. So there is a URL here, and let's access it to see what we have. And we can see that there are quite a few different endpoints. This is something new that we haven't seen within the CTF before. So the first endpoint that we can take a look at is listing all of the restaurants available. So let's head on over to our terminal and we'll just do a curl request to this endpoint. So we'll grab the URL here, and we'll do a / as well as the restaurants endpoint. Taking a look, it looks like we have 5, 0 through 4. So we can access all these kind of restaurants using the ID, which we can find here. But we will want to most likely list the menus for each restaurant. So let's head over here and let's use a get request and just start plugging in the different kind of identifiers. So we'll do ID of 1, or sorry, ID of 0. We could see, and we could also do attack S and JQ, visually see everything, make it a bit more cleaner to view. And we could see that there's not much here, just looks like a bunch of stuff that we don't really care too much about. So we'll head on over to, let's see, 1, and also it looks like almost the exact same stuff as before. But however, looking at maybe 2, we do see that there are different kinds of things that we have, and we also have a flag here. Because of this flag, we see that the price is $1,000. So we're going to need to figure out a way to exploit this, right? So we can retrieve the flag. And the first thing that we're most likely going to want to do is look at the different kinds of endpoints that we have. And we can see that there is a coupons endpoint based on the hour. So submit an hour as an integer from 1 to 24. So we could take on this coupon endpoint and see what we have to offer. Head back on over to our command, and we'll just modify the endpoint to say coupons hour, and then we'll say, let's see, 1. It looks like there's no coupons available. So once we hit the 20th identifier, so the hour 20, we can see that we do have a $2 off coupon, and it looks like it has a value of 3. Looking at the different kinds of endpoints that we have here, we can see that we also have an order. So we can order a specific item from a menu and use a coupon against it based on the hour. So we can schedule essentially an order. So we'll take this on over and let's see what we can work with. So let's go over to our curl request. We'll modify this ID. So we're going to be ordering from number 5, it looks like. So let's go over here to number 5. And we're going to want to do a tag X at the front, which will be a post because we're doing a post request. We'll want to do a tag H for headers, and we'll do a content type application JSON. We're also going to want to do a tag data, and we will supply it with our different kinds of values. So the first one that we have is the time. And we know that the time is going to be 20 because the coupons is 20. And if we look back over here, the coupons is based on the hour. So since we're looking at the 20th hour, safe to assume that we're going to need to also use the time as the 20th hour. We're going to need the menu item ID. So let's look at the menu item ID, which it looks like it's 5. So, excuse me, it looks like it's 2 because this is the menu. So come back down here. I will modify this to 2. So we'll change this to 2. And we'll change the coupon ID, which we can see right above there, is set to 3. So we'll just change it over to 3. When we run this, let's see if anything happens. Invalid item ID. So it doesn't look like that worked. Let's modify the restaurant as well as the menu item as well. Let's just modify both them. So this is the restaurant ID of 2. This is the menu ID, which is 5. We scroll back up. Here's the menu ID, which is 5. When we click enter, let's see what happens. And we see that the coupon was successful, right? We get 2% off, or sorry, $2 off. And sorry, the flag is not free. You owe us some money, as well as the total dropped down by $2. So it looks like that this is correct, but for whatever reason, we are still being charged a lot of money, and we don't have that money in our bank account. At least I don't. Maybe you do, but I do not. So let's try to figure out a different way to maybe bypass this. Something that you can always try when it comes to an e-commerce website or store, something along those lines, is you could try to just spam it with a race condition. In this case, it's not a race condition, so we're not going to try that. But what you can try is you could see different kinds of delimiters. And what I mean by that is you can set it to, let's say, 3 and then just put another 3, for instance. And we can click enter. We can see that 33 is not a valid ID. So that's not really going to work. Sometimes a delimiter can be a semicolon, a period, a colon, anything like that. So we could try a semicolon and see if it works. And we see that it is actually reflecting the value, but it's not showing anything. So that's not going to work. Maybe we could do 3,3. We could see that we get 4% off now, or $4 off now, and the value went down another $4. So it's safe to assume that this is probably our way of retrieving the flag. So what we can do now is we can maybe do just a bunch of 3s. So, 3, 3, 3, 3, 3. And we'll just keep going until we reach 0. All right, and after putting in a ton of different 3s, we can press enter and we can see that we did retrieve the flag. APISEC, perhaps you should consider a wallet. This was the first challenge done. So let's head on over to our notes and let's submit the flag here. So the second challenge says, this is why we can't have nice things. Apparently, someone found a way to bypass the coupon system. Now we've limited to 1 coupon per customer. We can see what we're working with. And it looks like it's the exact same endpoints, just the application appears to be different by the URL. So what we're going to need to do is we're going to need to go through all the steps over again. So we'll do the restaurants. So we'll do a curl on the Uber, and we'll just change this to Uber Orcs 2, and we'll supply it a restaurants, and we'll supply the restaurants endpoint. We click enter. We see that we again have 5. So we could try to do the same thing, which is the third endpoint, and we'll go over here, 3/menu, and we can see that we don't have a flag item in here. So we now need to find the flag item. So we'll go through each one just to see where the flag item is located. And it looks like it may be located in the restaurant number 4. So it looks like that the item is 7 and the restaurant ID is 4, but we also need the coupon. So let's head back on over to our command and we'll do a coupons slash 1, 2, and we'll keep going down the list until we find the coupon. So we found the coupon. It looks like it was the hour 12, so the 12th hour. And we could do the exact same command that we did before. So we could do attack X with the post, and we have all this crazy data, but we're not going to use any of these threes. And we're going to modify the menu items to be 7 as well as the time to be 12. We'll modify the restaurant to be 4 as well as just the URL. So we're pointing to the correct URL. And we see that the coupon, it has a value of 2. So let's just change the value to 2, click enter, and we see new coupon is provided. So this is a bit weird. Let's go back over to our command and see what we've done wrong. And it looks like that it only has a coupon, not coupons. So let's quickly modify this to say coupon. And we can see that we do get the $2 off, and we do need more money. So let's try the same exploit again by doing a comma and then a 2 there. And we can see that only 1 coupon allowed per order. Now, like I said, there may be a different delimiter. So let's try to do, let's see, a semicolon. Looks like we broke JQ. So let's just take that out and let's see what happens. And we see we get an internal server error. So that's obviously not right. What if we tried to do maybe a colon? Say JQ also failed. So I'm assuming that didn't work. A period, that also didn't work. So what if we just don't put anything in it? We see that there didn't need to be a delimiter, that we can just easily just add another 2 and we get $2 off again. So what we can do now is we could just spam a bunch of 2s to the server, and we could see if we do get the flag. Now that we have enough coupons, we can click enter and we can see that we retrieved the second flag, APISEC, too many coupons. So let's head back on over to our notes and submit the flag. And that's all for today's episode. I hope you did enjoy. If you did, make sure to leave a like and subscribe to the YouTube channel. Helps me out to create more content related to API security as well as application security. Here we have the final challenge for the API Security 2024 CTF. It's called Mu API. This was by far the most challenging of the bunch when it comes to difficulty. So please take your time with this. I'm probably not going to post a video for at least a week and a half, 2 weeks related to this challenge because it's so difficult. So just try it out. Let me know what you think about it. And if you did manage to figure it out, let me know in the comments down below. But this is a multi-step application that you need to figure out and find the flags for. That'll be the end for this episode. I hope you did enjoy. Please like, subscribe, and I'll see you in the next one. Take care. So in this episode, we'll be looking at Mu API. There are 3 challenges. The first one is data-driven discovery. Turns out the pen test report was never actually read by the mages. Typical. But it's not like anyone can actually get into our systems, right? The report is pretty vague. And we have a target URL here. So let's access this URL and see what we have to work with. We can see there's not really a ton of information. There's just a lot about, it looks like this is a musical API that we're going to be working with. There is a sign up page and as well as a login page. So let's see if we can sign up and see what we have here. So let's quickly put on Burp. So we'll head on over to Burp Suite, load this up. Alrighty, so we have Burp Suite set up. Let's head on over to the open browser and let's just paste in the exact same URL into our Chrome here. So we could just put in something random. So we'll do like admin@admin.com. We'll do test and test. See if we can register an account here. It doesn't look like it's working. Let me try something a little bit more advanced. So password 123 bang, password 123 bang. And it doesn't look like it's actually doing anything. So we will not worry about that. Maybe we could try to log in. I don't know if there's maybe a user enumeration that we have to work with. So let's do login, and it doesn't look like anything happens there either. Head on over to Burp. Maybe there's something there that we could check out. So let's go to the history, and it doesn't look like there's any API endpoints here. Maybe there's something inside of the JavaScript. If we go over to the JavaScript, we can see that nothing really gets pointed out. Maybe if we look up, /API, something shows up. And it doesn't look like anything has to do with the API over here either, so we're not going to worry about that. So not really many options at the moment. Again, we didn't see too much happening within this website. So we may have to do directory brute forcing. So ForexBuster allows you to do directory brute forcing recursively. Unlike GoBuster, you can do either one. Just ForexBuster is a little bit more advanced in that sense. So we can do tac URL, and we'll paste in the URL here. Again, let's remove this, and we'll also do a tac W for word list. And we'll do user share word list. We could do derb. Maybe we'll just do common.txt to start. And let's let it run, and it looks like we get rate limited there. So we're not going to be able to do too much having to do with brute forcing. Maybe we can lower the threads just a little bit. So let's do maybe a tac T of 2. And it looks like we also get rate limited there. So we're not going to be able to do anything related to brute forcing. We could try to use the tac rate limit as well. So we could do rate limit to, let's say, 2. And let's see if anything happens with our scan now. It looks like it is going, but this will take some time. So we can either wait for it, but because of the time frame that I have for this challenge, I'm not going to wait for it. But we can do a /API here, and this is how I normally go about testing APIs. I start to do some basic enumeration. So we can see here that it says endpoint API does not exist. Now, this is a little bit strange, right? Because well, we have an error here, and it does reflect. So I wonder if we do, let's say just XSS payload, right? So source equals X on error. We could just do alert 1. And we see that it does get reflected. So this is a pretty good start. What if we try to do maybe a /v1? Is there something there? No, doesn't look like anything really happens there. So what if we try to do a few things? First, we can try some basic things. Since we can't really do SSRF because SSRF requires you to have some form of URL parameter or PDF generation script, which we do not have currently. We could try SSTI or server-side template injection. So what we can try is let's just do a basic payload. So we'll do 7 times 7 just to start. And we could see that we do get 49. We can head on over to payload all the things, and we can just look up SSTI, and we'll see that payload all the things has a server-side template injection for various kinds of templates. It's not just Python. It's also for things like SMP.NET and other things of that nature. So let's head on over here, and we can look at Python. We see that there's just a bunch of stuff, and we can see that there is an os.popen.read. So let's head on over here, and this is going to help us figure out if there's RCE. So we'll copy over this payload, and we will paste it into our URL and see if we get any information out of it. And it looks like there are bad characters, but we do see that we do get the IDs back of the user on the back end, which means we are getting RCE, which is great. This is great. So let's try to modify this a little bit, and we'll just do a tech ls tech la. I just like to see what is on the server. We can see here that there is a .secret key, which is pretty interesting. I'm not sure what that's all about, but we could try to see what that is. So let's head on over here, and we'll just do a cat on the .secret key. And we can see we got an internal server error. So that's probably not the way that we want to do things. So maybe we have to do, I don't know. Let's try to see if we could do a cat stgi.py. Let's see if anything happens here. And it looks like we do get stuff back related to the application. So if we go back one directory, we can see that there is a flag.txt. And all you have to do here is if we do a /flag.txt, we could do a cat, click enter. And we can see that we do retrieve the flag. APISEC, you got RCE 223. So we copy this, we can paste it into our notes here. So just put flag here, and we'll paste in the first section. So the second section says, breaking into admin territory. Check out the new music streaming service that the mages have been working on. IT said they had a pen test done, but we actually have no idea what the results were. It's probably fine though, right? Again, it's the same exact thing that we were doing before, so we'll just head on over here, and we'll actually go to our history just for simplicity's sake. So go here, we'll take our payload and paste it into our Chrome. We can see here that we do have an app directory, so we'll go into the /app again, and we could see that we need to put %20 here. There is an API.py section. So if we do a /API.py and we'll do a cat command onto it, we can see that we get a bunch of different things, something that just doesn't make much sense. So let's scroll down a little bit. Let's see if we find anything of interest. And it doesn't really look like too much is going on, but because of what the challenge said, I'm assuming we have to do something with the API. And it looks like there is something here. So we have a file with a directory path that we probably wouldn't be able to guess originally. So if the pin is equal to the current app config of download key, then we can retrieve the download file. So we're probably going to need to gain access to this file somehow, and we're going to need the pin. So what we can do now is let's try to just grep and maybe find the pin. So we'll do a grep tech R, and inside of quotes, we'll just do download key. And let's see if maybe this works. Looks like it's a bad request, and that's because we need to put again our %20 and then %20. And we could see that we do potentially retrieve the pin. Do we actually retrieve it? Yeah, here we go. So 2190 is our pin. So let's head back over to our original request, the API.py, and let's head on over to that endpoint that we just previously saw. So let's go to here. Let's copy this and we'll just send this to repeater so we have a brand new request. And inside of the p open, we'll change this. Or you know what, we don't even need this anymore really, because what we're going to do is we're going to go to that specific endpoint, and then we'll do a pin, and then we'll equal it to 2190. Click send, and we see 404 not found. So for whatever reason, this does not seem to work. Maybe we have to keep the API. So let's do API and stick to v1, and we can see that we do get the PDF. Okay, so let's take this URL and let's paste it into our Chrome. When we click enter, we retrieve the report.pdf. Let's click open. We can see that there is a security report, and at the bottom here, which I could zoom in a little bit, there we go, we retrieve the flag. So this was supposed to be apparently flag 1. Apparently I wasn't supposed to do it this way. Apparently this was supposed to be an SQL injection, but I just so happened to find a different way in, I guess. So we'll paste this over here, and we'll do flag, and we'll paste that in to our notes. The last section says above and beyond. We just got word that there's a privilege escalation vulnerability on the system running Mu API. This was just disclosed to us now. Perhaps someone can figure out what's going on. Okay, so this is probably the most challenging part. If you don't have a VPS or some form of server that has a public IP address, this is going to be extremely difficult. That's why I had to ask Sloppy Joe Pirates, who does a bunch of CTF write-ups. I strongly encourage you to check him out in the description down below. He does a bunch of CTF walkthroughs. He actually showed me an interesting technique about how we can get a free public IP address, quote unquote, for CTFs like this. So we'll head on over to the terminal, and we're going to use a tool called ngrok. If you don't have an account, set one up. It's pretty easy to do. And we're just going to do TCP, and we'll stick to, let's say, 4444. And in a different terminal now, what we're going to want to do is we're going to want to expand it just a little bit so we can see the URL that we have to forward to. And we're going to do ncl BMP 4444. Essentially what's going to happen is we're going to take this TCP, we're going to run a reverse shell on it to receive a shell, and it's going to forward any of the traffic from this to our local host, giving us the ability to have a secure connection. So what we're going to do is we're going to go over to revshells.com. So we'll head on over here, we'll go to revshells.com, and here's a fantastic place where you can find a bunch of different payloads to use when it comes to rev shells, and we'll just modify our IP address. So our IP address isn't going to be our local host, it's going to be this TCP link here. So we'll just paste this in, and we'll also paste in our port, which is this right here, 16831. So we'll take that port, do that, and we will use our Burp Suite. Actually, no, we're not. We're not going to use Burp Suite just because there's going to be a lot of headache when it comes to the %20. So we'll just come back to the URL, paste it in, and we'll click enter. After a few seconds, you should see that you now get a shell. So if we do who am I, we can see that we are user on the box. We could do an IPA just for clarification, and we could see that we are on the box itself. Now, this is perfect, right? Because now we could see all the different things. Well, within this box, we have RC, everything is good. We could do a sudo tac v just to see the version of sudo. And it looks like we're using sudo version 1831. Now, this is a vulnerable sudo version. So if we go to sudo version 1831 exploit, this is the sudo vulnerability of CVE 2021-3156. What we have to do is we have to transfer these files over to this vulnerable box. So we'll come back over here and we'll just zoom in a little bit. This is going to be the main terminal that we're going to be working with for just a while, because you'll see here in a second, if we try to do curl, that's not a command found. If we do wget, that's also not a command. So we need to find a different way of transferring files to this vulnerable box. We could do an ls. We could see that we do have access. We could do a pwd to see where we are within the box, and it looks like we are in our home directory. So we could try to do a few things, right? First, we can see if we can do just a basic base64 transfer, which is kind of ugly. It's not the easiest. Essentially, what we're going to want to do is you're going to want to take this information. So we'll just go to the raw output. We'll copy it over. We'll paste this into shellcode.c, and we'll do a cat shellcode into base64. We see here that we have just a bunch of random data. So we can copy this over, and now we can echo this base64 into shellcode.c. And because we're not in a stable shell, it's not going to work. So we're going to have to do a stable shell. And to do a stable shell, we're going to want to do a Python 3 text c import pty.spawn/bin/bash. We can click enter here. We can see now that we have a semi-stable shell. So now we could do export term equals xterm. We could do a control Z, and then we could do a STTY raw echo and then foreground it. So now we have a perfectly stable shell. So now what we could do is we're going to echo this into shellcode.c, and we'll paste in our base64. So the reason why this didn't work is because this actually has a bunch of new lines associated with it. So we're going to have to take this and remove all the new lines. So we can create a new file here, just have it be a text file. We see that this is just all new lines. So we could do a control F, and we could just put a \n, and we can replace it with nothing. So when you click enter, now we just get a long string of things. So we can go back here, we could do echo, and we'll do again the same thing, shellcode.c, and we'll paste in our base64. And now we could do base64 tac t to decode it. And if we do a shellcode.c, we see that we transferred the file successfully into the vulnerable box. And we're going to do this for each section. So now what we could do is we can now see if this does work. So we'll do just make, and it looks like it did. We could do an ls, and it looks like there is the exploit script. So now all we have to do is a /exploit, and we can see that we are root. Who am I is root. We could do an ls to see where we are. So pwd, looks like we are still in the home directory. So we can go into cd root ls cat flag.txt, and this is the final flag of the CTF. So let's copy this and let's paste it into our notes. And that's all for this series, everyone. If you did enjoy it, please like and subscribe to the YouTube channel. It helps me create more content having to do with web application security as well as API security. I hope you did enjoy this series. This was a fun one. Shout out to APISEC as well as Maltech Solutions for putting on a fantastic CTF. If you do want to have some action with the next CTF that's happening May 21st, be sure to check out the description down below to register for the APISecCon 2025. Please, if you have any questions, feel free to drop them in the comments down below, and be sure to join the APISec University Discord. I'll be on there. You can chat with a bunch of the ambassadors and community. Help yourself grow within the API security space. Other than that, please like, subscribe, and I'll see you in the next one. Take care.